So we are continuing our coverage of Severe Weather Awareness Week this week with a look at how UW scientists are trying to better study tornadoes.
And Hattie got a chance to talk to one of those scientists. She's here with more. It's pretty interesting stuff.
Yeah, Leigh Orf, he's a scientist with the UW, has been working on some fascinating things when it comes to tornadoes. Here's just part of our conversation. I'm with Leigh Orf this morning. He's a scientist at the UW-Madison, talking about a computer model simulation that he made of a supercell thunderstorm. Thanks for coming in this morning, Leigh.
It's my pleasure, Hattie.
All right, so I want to first start by taking a look at this video. It's fantastic video to watch. Can you explain what we're seeing?
Sure. We're looking at a computer simulation of a supercell thunderstorm, looking at the cloud and rain field. And you're seeing the tornado descend to the ground, the wall cloud that's above the tornado, and pulses of rain in the storm. A lot of information in these simulations, and I've spent a lot of effort trying to bring them to life in a way that operational meteorologists and spotters can understand.
Yeah, so for everyone that's looking at that, that's not actual video of a tornado. It's what the computer made. And the interesting part with your model in this simulation was that the storm actually spawned a tornado, like the real-life one did.
It spawned, exactly. So we were patterning this storm after the May 24th, 2011 EF5 in near El Reno, Oklahoma. That was part of the big outbreak in 2011. As you know, there were several very high-profile tornadoes that year. We had Joplin, Missouri, Tuscaloosa, Alabama, El Reno. So what we tried to do is take the environment that was adjacent to an observed storm and sort of freeze it and then grow a cloud in that environment. And when we did that, it took several tries, but one of our simulations produced a storm that looked a lot like the actual May 24th, 2011 storm, which produced a long path, long track EF5 tornado. So it was on the ground for over an hour, and it's just grinding through. And our simulation did something very similar. And this isn't the first time that supercells have been simulated and produced tornadoes in numerical models, but what we did is sort of like going from a 5 megapixel camera to a 20 megapixel camera. We really increased the resolution and the fidelity of the simulation, and we're now pawing through the data trying to figure out what's going on.
Yeah, with that information, what do you expect to learn from your simulation?
The big question we're trying to answer in this research is, why do some supercell thunderstorms produce these really powerful, devastating tornadoes, while others don't? So we're trying to sort of peer into the guts of the storm to see what's going on inside that leads to that tornado, and not just any tornado, but the really long track, really long path, devastating ones.
And for forecasters that are in the field, then meteorologists that are working to forecast these storms, the National Weather Service or our TV stations, how will your research then help us to better forecast in the future?
And that is always the goal with this kind of research: give better forecasts. We want to be able to get people out of harm's way. We want to have forecasts that are more targeted regionally, so we only have a small area where the warning is issued, and people outside of that warning don't necessarily have to take cover. But yeah, essentially, if we understand these storms better, then we can forecast them better. It's
so
difficult.
That could be better lead time, possibly?
Better lead times, and then when a warning is issued, we should hopefully have a more narrow region where we're going to predict that the tornado is going to actually occur. Forecasting tornadoes is a very challenging problem. So ultimately, the end result of our research, we hope, is that after we understand these storms better, we'll understand storms that don't produce them better as well.
Well, that is fascinating work, and I'm sure it's going to lead to many advances for forecasters and the public in the future. So I want to thank you for your research.
Sure.
That's second semester kind of stuff, isn't it?
No, that is way beyond
That's way past second semester kind of stuff? That's fascinating.
He's been working on this for 10 years.
Holy smokes.
Yeah, and just the definition in that computer forecast model is impressive. Yeah. So I'm sure it will lead to great advancements in forecasting.
Well, I'm just sure, too, the alternative is something a lot more dangerous, trying to kind of, when he said peer into the guts of the storm, I mean, you can't do that without either doing something like this or driving straight into it, you know?
Right, and you don't really want to do that.
No.
So, not a good thing at all. So impressive stuff that he's doing, just amazing technology that allows us to do this. Many unknowns with tornadoes, why some spawn a massive tornado and others likely with the same conditions don't. So we'll learn a lot of things.
Tornadoes are scary things as well.
Yeah.
You can remember to keep up to date with the weather in our area. All of our meteorologists populate this Channel 3000 weather app that you can get on your phone. Thank you, Heads. That was interesting.
You're welcome.